Hi, I welcome you back to this wonderful journey of learning structure analysis with STAAD Pro. I'm Sudeep and I'm a structural engineer and the leader of STAAD Pro technical team at Bentley Systems. I have been working on STAAD Pro at Bentley for 17 years, and prior to that, I have 6 years of experience as a structural designer. In the last session, we learned how to assign a standard category of a section from a specific database to members in STAAD Pro. We had chosen the parallel flange section from the European database for illustration. In this session, we'll talk about assigning special sections which are built out of the standard sections in the database. But before we go forward, please take a moment to hit the like and the subscribe button, which will help you get notified when we post a new video. Our first illustration in this case is the T-section. T-sections are carved out of the standard I-shaped sections. So let us consider this goalpost frame. Now we want to assign steel sections to the various members of this particular model. So we go into the Properties tab and click on the section database from the Properties whole structure box. You know all of this by now. Now let us say that we want to assign a European IPE A80 section to the column members of the goalpost frame model, and we want to assign a T section that is cut out of the IPE A80 section to the beam member of the goalpost frame model. So let us first go to the European database. By default, we are in the IPE shape. So we scroll down and select the IPE A80 section. Now, as you can see, by default, the section type that would be assigned would be the ST section, which would mean the standard section that has been defined in the database. Now, this section is intended to be assigned to the column members, as I've said. So let us click on the Add button, and we can see that this section has been added to the Properties whole structure box. Now, to assign it to the beam member, we need a T section that is cut out of the IPE A80 section. So the type specification cannot be ST, which would mean the standard section. We need to select the next option, which is the T section, which is cut out from the same section of IPE A80. Now, once we have said that we want to define the T section, we can click on Add and now close. Now, we can assign the first section, which is the total or the whole IP80 section, to both the column members. We ensure that the assign to selected beams procedure is highlighted, and we click on the Assign button to assign this section to both the beam members. Now, we want to assign the T section that was cut out of this particular section to the beam members. So we use cursor to assign assignment method this time. So we click on the Assign button, take our mouse over the beam and hit the beam with our mouse, and we have the T section being assigned to the beam member. Now, we had actually discussed all of the assignment methods in details when we had discussed the assignment of concrete members. So you can go to that section if you want to know the details of the assignment methods by clicking on the link that is appearing on the screen right now. Now, let us go into our text editor to find out what command line has been defined for the T section. So we click on the Save button, and we can see that if we go into this member property European specification, we can see 1 and 3. Member number 1 and 3 has been assigned with an ST IPE A80 section, which means the members number 1 and 3, which were the column members, has the standard IPE A80 section that has been assigned from the database. Member number 2, which was the beam member, has the T cutout of IPE A80 section assigned to it, and thus instead of ST we have TIPE A80, which would mean that it's a T section that has been assigned to this beam. Now let us go out of the text editor and let us select this particular member, and let us try and view the rendered image of this view. So we click on the new view to select only this beam in our view. So we go to the view option and click on 3D rendering, and you can see that beam is being highlighted. If we actually highlight that view, you can see that what has been assigned is nothing but a T section as we had expected. Remember that the section properties of the T section would be calculated from the I section from which it is cut. For example, the cross-sectional area will be half of the I section from which it is cut. The moment of inertia would be needed to be calculated based on the centroidal axis of the cut section. So let us now create a bracing member in the model. So ensure that you are in the geometry page, click on the add beam option, and we click on these two endpoints to create a bracing member. Now let us intend to assign a double angle section to the bracing member. So what do we need to do? Well, we need to go to the properties option, and we need to go to the properties whole structure box section database, and let us go into the European database, and we select the angle section database. Now let us, for example, select an angle section 40 by 20 by 3, and we ensure the type specification as double, but by default it would be the ST section, or you can select the RA section. Now in case you have a confusion about the ST angles and RA angles, we had really discussed this in great details last time. You can access that session by clicking on the link that is appearing on the screen right now. However, our objective is to define a double angle. Now there can be two ways in which we can define a double angle. In one case, the long legs can be placed back to back. You need to define the spacing between the angle sections. The other way is to define the short legs back to back. Again, the spacing needs to be defined between the section. In case of equal angles though, where the legs of the angles are equal, you can have only one configuration. The cross-sectional area for double angles will be double of that of the standard section. The moment of inertia would be needed to be worked out based on the two angle section and the spacing between them. So let us say that we want the long leg back-to-back double angles. So we select on this appropriate option LD. If we want to specify the short legs back-to-back, we need to click on this option called ST. But since we want the long legs to be back-to-back, we have specified LD. Now, then our next job is to specify the spacing between the two angle legs. So let us say that it is 25 millimeters. So we put that as 0.025 meters, and we click on the add button. We click on close. Now this section has been added to the properties whole structure box against the reference number of 3. Now again we use cursor to assign and assign it to the diagonal member. Now again let us go into the text editor to see the command line for this particular section, and we can see that the member number 4, which is the diagonal member, has now been assigned with a LD angle L40 by 20 by 3. LD means double angles with long legs back to back. SP is the spacing between the angle section, which has been specified as 0.025 meters. So now we understand what the command line is. If the angle had been so configured that the short legs of the angles were back to back, then instead of LD, we would have had SD. Now let us go out of the text editor and let us select this particular diagonal member, and let us click on the 3D rendering view to see how the section has been assigned to it. So we go closer to this section and we can see that we have a double angle that has been assigned to the specific diagonal member. Again, we know that the cross-sectional area of the double angle members would be double that of the angle section, and the moment of inertia needs to be worked out based on the spacing of the angles. So we can now close this. Now we will talk about the double channel sections. Again, there can be two categories of double channel sections. Double channels back to back, as we see on the screen, with a spacing between them, and double channels front to front with a spacing between them. And we would need to specify the appropriate spacing. Again, the cross-sectional area would be double that of the single channel section, and the moment of inertia would be needed to be worked out considering the space in between. Let us see how we can specify these sections in STAAD Pro. Now remember that in the beam member of this goalpost frame, we had our section R2 that is assigned, which was an IPE A80T section. Now let us say that we want to change it to a double channel back-to-back section. Now let us click on the section database, and let us say that instead of going to the European database, we select a channel section from the American database. So let us select on channel, and let us say that we want to have a double channel back-to-back created out of the C12 by 30 section. So we select the C12 by 30 section. The default is the ST section or the standard section, but we need a double channel back-to-back, so we click on this D option. The double channel back-to-back option is represented by D, and if you had wanted to assign a front-to-front double channel section, you would have needed to have clicked on this FR option. But let us say that we want to assign a double channel back-to-back, so we select on this option. We need to specify the spacing between the channel section. Let us say that is 30 millimeters. So let us say that it's 0.03 meters. Now we click on add, and we have added this to the properties whole structure box against reference number of 4. So let us take this section and assign it to this beam member. You will see how R2 changes to R4. Now that would mean that we have the double channel section back to back has been assigned to the beam member. Now let us go quickly into the text editor to find out the section that has been assigned there, and we see that member number 2 now has been assigned with an American section, which is C12 by 30, but it's prefixed with D, which means that it's a double channel back-to-back section. If it had been double channel front to front section, the prefix would have been FR. Now let us go out of the text editor and let us select on this particular member, and let us view the rendered image of the beam member, and we can see the section has been assigned. We can turn it around to see it more clearly, and we can see that a double channel section now has been assigned to the beam member with the required spacing in between. So today we have learned about how we can assign special steel sections that can be built out of the standard steel sections to the members. In the next session, we'll talk about user-defined sections, sections that are created out of steel plates. If you have liked this video, please do hit the like and subscribe button if you have liked my efforts. I hope to see you in the next session. Till then, bye-bye.